This is Berkeley's Statistics 243 class for Wednesday, September 17th, the 8th class of the semester. All right, let's get started. So actually, I was meaning to ask this last time. How many of you have seen regular expressions before and you worked with them some? So some smattering of you, maybe a third of you? Okay. And how many of you have done a fair amount with sort of text manipulation and document manipulation? Maybe that's going to be an overlap with the previous question, but with whatever. Yeah. Okay, so a few of you? Okay. All right. So I left off last time, I'd just given a few examples of some of the base R functions that are used for dealing with strings. And a few of the core ones that get used a lot with regular expressions are grep and gregular expression and gsub. And up until a week ago, the other times I've taught this class, we've used these functions quite a bit. But there's this package that's been out for a while called Stringer, or String-R, I'm not quite sure how it gets pronounced, that has some nice sort of wrappers for these functions. And so I decided when I was preparing this material this time around that I would switch over to that syntax. So that's what we're going to use this time. And there may be a few cases in the PDF where I'm using some of the old syntax, and that's just because I didn't catch every time that I was supposed to make the switch from one context to another. Okay, so let me switch over to the PDF briefly. So I tried to sort of tabulate up sort of what were the core functions that would be useful in String-R, and sort of generally saying what they do. And so basically, if you're just trying to figure out whether a particular pattern is in one or more strings, then that's where string detect comes into play. And that's just going to return trues and falses. But if you're trying to actually either return the matching positions of where the pattern was found, that's string locate. And if you're trying to actually pull out the thing that was actually matched, then that's string extract. And if you're trying to replace in for the patterns that were found, then that's going to be string replace. And they're all going to follow a very similar sort of syntax pattern, which is here, which is the name of the function, namely one of those guys, and then the R character vector, which is going to be the set of strings that you're operating on in a vectorized way, and then the pattern that you're looking for. And then if it's the replace context with string replace, then you're going to have what to replace the pattern with. So everything, unlike with gsub and gregular expression and whatnot, everything should fall into this nice sort of systematized way of doing things. And the only difference with whether there's an underscore all at the end is whether you want to detect or replace or whatnot all of the pattern, all of the cases where a pattern is found in a particular string, or just the first one. So that's the only distinction with the all there. Okay, so as an example of this, and then there are a few sort of additional sort of helper functions that can get used to sort of change the behavior of how we do the searching for the patterns. So the way that you do that is a few of these are fixed and ignore.case and Perl, and they're basically sort of toggles that allow you to switch back and forth between different ways of having the matching work. So an example of putting this all together is we load in the package. We have a character vector of 3 different strings in which we're going to look for some pattern or a set of characters. Yeah, Daniel.
Are we going to do an example of Perl?
Not with the language Perl, but there are different kinds of there are different variations on how regular expressions work, and one of them is the Perl variation. Okay. That's what I mean by Perl here. Yeah. So if we were to go in and look in this character vector for APP, well, it matters whether or not we are trying to look for exact match in certain terms of uppercase, lowercase, or whether we don't care about the exact matching of uppercase, lowercase. And so if we were specifically looking for APP, all lowercase, we wouldn't have this bit in here. We just pass it the string and the thing that we're looking for, and it would return where it located those. But this is an example of using one of these sort of toggle type functions that say, In this case, I want to ignore the case when I'm looking for this pattern. So we could have used fixed here to say we're not going to use a regular expression, and that will, you don't have to say fixed if you're not using a regular expression, if you're just looking for something simple like this. But if you're not using a regular expression and you use fixed, it may be faster because it's not having to interpret things as regular expressions. And then Perl if you use Perl here, for example, if you use Perl instead of ignoring a case, it says whatever pattern in here is going to be interpreted in terms of the Perl style of regular expressions. Okay, so in this case, this returns where it found the matches. So the first three in this one, it didn't find the matches anywhere in this one, and it returns from the first to the third character is where it found the match there. Okay, so now what we're going to do is we're going to dive sort of deeply into this idea of regular expressions. And sort of the basic idea here, which many of you are probably familiar with, is we're not just looking for some fixed sequence of characters that we know exactly in advance. We're looking for some more complicated pattern, and what we need is some way of expressing different kinds of patterns. So maybe I'm creating a spam filter, and I'm looking for patterns that look like they would be spam kinds of characters. We'll see that in a second. Maybe I'm looking for email addresses, and I'm trying to extract email addresses from a particular document. Well, that's not going to be some fixed set of characters. It's going to be some sort of pattern that I have to recognize. Or maybe I'm looking for phone numbers, or there's sort of endless different possibilities of different ways that you would be looking for patterns. And so this idea of regular expressions is, computer scientists have this term called the domain-specific language. And what a domain-specific language is it's a very specialized language for doing a specialized task. And so regular expressions are an example of a domain-specific language. And this language gets used, we're going to see it used in R, but it also gets used if you can do these same sorts of things in Python. You can do them in Perl. You can do them from the command line. We could have used regular expressions with grep from the command line. We didn't actually go into that in much detail, but we could have done that. And they also get used in some of the Unix utilities like sed and awk. And grep, I guess, I already mentioned. So in learning this language of regular expressions and how to use it, and sort of getting our minds in the mindset of how do we interpret these sort of complicated sequences that will represent the patterns, this will set you up to use them in any context, but we're just going to do it in the context of R. Okay, so the sorts of things you can do are all the sorts of things that you might expect from anywhere from cleaning documents to extracting information from documents to creating a whole data set based on some textual information that you're then going to analyze statistically, to pulling stuff off the web and pulling information in from HTML files or anything else that you get on the web. So sort of the domain in which this stuff is useful is pretty broad. Okay, so my thought of what we would do today, and then as carrying on into Friday when we should finish this, is basically I'm going to present to you sort of some of the rules for how we specify these regular expressions for finding particular patterns of interest, and then we're going to try and look at some particular examples and see what you guys come up with in terms of how you would try and find in particular kinds of patterns. And one of the things that I think is interesting and useful when we're doing regular expressions is to see what different people come up with. Because like doing anything in R or programming language, there's usually like 7 different ways that you could do any particular thing. And they may be essentially equivalent, or some of them may have strengths and weaknesses relative to each other. So it's interesting to sort of compare notes on how people do different things. Okay, so first of all, one thing to realize is there's a set of characters that are used in expressing these regular expressions, and those are special characters. And if you want to actually look for any of these particular characters as actually the characters themselves, you have to escape them. In R, you have to put 2 backslashes in front of them to say, I'm actually looking for a beginning parentheses. I'm not using the parentheses to indicate the syntax of the actual regular expression language. So we'll need to keep that in mind.
Question.
Yeah.
In R, is the double backslash, is R recognizing the double backslash, or is the first backslash escaping the next backslash to escape the following?
That's a good question. So something like /n stands for a new line. So it sees the slash, and it is then expecting the next thing is not going to be just a regular character. It's going to interpret that as together as something. So then I guess, yeah, I'm not sure. I don't have a good answer for that. Anybody else have thoughts on how R might be treating that? I might come up with something better answer offline, and if I do, I'll send out a note. But it's a fair and a good question. Okay, so the first thing we need to do is we're going to start, instead of just saying I want to find the letter A, the idea is I want to find a character in a particular class of characters. And so this will immediately start to sort of get us away from looking for some fixed sequence of characters to looking for something much more rich. So I can create a character class by putting anything I want as single characters in these square brackets. So if I look for square brackets and then these numbers in here, it means I'm looking for a 1 or a 3 or a 5 or a 7 or a 9. Or here I'm looking for an A or a B or a C or D. And here, this minus is a special character in our regular expression language. So here I'm looking for any single digit between 0 and 9. And I can combine these things in sort of interesting ways. Here I'm looking for any digit between 0 and 9 or any single character between A and Z. Okay. And here I'm looking for a space or a tab character. Okay. So I can basically combine these things together. And if I want to do a negation, I can say I want to look for any character that is not a lowercase a or a lowercase b or a lowercase c or a lowercase d. And that's what the character means in the beginning here of the character class. So we can construct our own little character classes in this way. But there are also a bunch of character classes that are already named for us. And they follow the format of you specify the brackets and then you do inside of 2 colons, you do the name of the class. And so the different classes that we could use are a digit, so that just corresponds to 0. That's the same as the 0 to 9 up here. Or alpha should be any lower or uppercase alphabetic character A to Z. And alphanumeric should be any digit or any alphabetic character. Lower is any lowercase character, so on and so forth. They're usually sort of self-explanatory. Although once you get into the more specialized ones, you might wonder what exactly counts as punctuation and what doesn't. And in that case, you then have to go look it up. And there's some useful help information in R if you do help on regular expressions. Okay, so it turns out if I actually want to use this syntax to specify a character class, I have to actually need double brackets because the outside brackets say, hey, when this is being interpreted, it says, hey, this defines a character class. And this inside bracket is basically just saying it's one of these special named character classes. So you have to do the double ones. And so then you can basically combine these things as well. If I wanted to make a character class that was alphanumeric characters augmented by underscores, and you might see where I'm starting to go with this of thinking about email addresses. This is going to be a new character class that is the old character class plus 1 additional character added onto it. And I could do that, sort of as much as I want to, as long as I've got the outer brackets. Okay. And it seemed like we found out 1 or 2 years ago when we were using this syntax in R that we needed to use the Perl syntax, and that the Perl equals true is this is one case where I didn't do the switch of all the syntax. That's if you're using the old style base R syntax, but oh, right, here it is. This is actually what you would need to do if you were doing it with the string R functions. Yeah.
This might be jumping ahead. We could totally save it for later. So let's say you wanted to look for any alphanumeric followed by the @ symbol. So
yeah. So then we're going to construct our thing as the character class, whatever it is that you want to put in that character class, and then literally we're just going to put the @ next to it.
Oh.
So one thing I guess I skipped over that's in the notes here is this idea we can still look for what are called literal characters, which is literally looking for the exact character we specified. Or we can look for these character classes. And those are the sort of things that we're looking at right now. And then we're going to get into all of the different ways to modify this beginning language that we're developing here. Okay, so I'll switch over quickly just to see this example in R. So here I'm going to here I'm taking the example of looking for any situation where I find a digit or an underscore. So I'm going to take these things which look like email addresses, I'm going to pass that as my first argument. I'm going to use this Perl sort of add-on function to say I'm using Perl-style regular expressions because I've got the digit class in here. And then you can see what I'm doing here is I'm creating a character class that includes any digits or an underscore. So that's what I'm looking for, is any single digit or any underscore. And so if I do that, then I find that I need to load the package in. And it says, okay, I'm just going to return booleans. Yes, I found Or no, I didn't find a number or an underscore here. I did find one there, and I did find one here. So fairly straightforward in this case. Here's another example where I'm creating another character class, and I'm going to look for any case where I find a space or a tab in these particular set of strings here. And so again, I'm just going to get falses and trues. Actually, it looks like I got the same ones just because of by happenstance of how I constructed it. Okay, and if I wanted to then say not just detect it, but actually sort of see where the matching is occurring, one of the things that you're going to find as you start to develop, you're going to have a problem that you need to face in real life, or you're going to have a problem that I assign to you, and you're going to start to develop. You're going to start to develop your regular expression syntax that you hope will search for that pattern. And there's going to be an iterative process where you're going back and forth and saying, okay, let me try this and see if it works. And you're going to want to see what was actually matched in the strings to see if you're actually if your syntax is actually working. So in this case, this is just a simple one, so it's not really getting at that fully. But we can see, okay, where did it find the spaces or the tabs? Okay, well, it didn't find them anywhere in the first one. It found a space from the 9th through the 9th character in this one, and it found spaces from the 5th to the 5th and the 12th to the 12th characters here. And I could also do the demo of extracting out what the matched patterns here. So here's an example where this is a little bit more complicated, and it already gets into some of the additional syntax that I haven't actually gone over yet, but it's give a little bit of a preview. This says look for whatever follows here only at the beginning of the string. That's what the caret means when it's outside of the character class square bracket. So here I'm looking for an uppercase character starting the string, followed by lowercase character, and what this means is look for one or more lowercase characters following the uppercase character. And then it says literally look for a space after that. So starting to sort of construct more complicated examples. And in this case, since this was the one where I had those names of people, I'm looking for something that starts with an uppercase character and then some number of lowercase characters in a space, and so it is going to match this particular string here. Okay, so, and here's just an example of doing a replacement. I'm looking for lowercase j's that start a string, and I'm going to replace them with uppercase j's. So in this case, this is again that same one with the John and the Jennifer and the Juan. This originally was a lowercase j, and this was a lowercase j, and this was an uppercase j. And as a result of doing the string replace, it printed out the resulting output with the substitution in place. Okay, so any questions before we jump into me posing an example question to you? Okay, so take a minute and see if you can figure out how you would search for a spam-like pattern. And sometimes it's often useful to sort of think about examples of things that you might want to be looking for as the pattern. So here, you guys can all think of what sorts of spam patterns you might see, but here are some obvious ones that you've probably seen in your own email. Either Viagra with a 1 in it, or fancy replicated watches with an exclamation point and an @ in it in place of the characters, in place of the alphabetic characters. So try and think about how you'd construct a regular expression that would pull out cases where there's syntax like this in the middle of some string. Okay, so what did people come up with? So you can volunteer.
Well, you could look for any special characters within a word.
Okay, so
Like
how? Yes.
start at like the second character. You know, look at the first character. If it's a letter, then you're expecting a word, and then somewhere in that word, if you have a character that's not a letter.
Okay.
perhaps.
So how would I actually put this into practice?
Well, is there a class for special characters, or would you have to create it?
Yeah, so you might have to create it. Maybe the special characters would be the punctuation class. Madeline?
So probably you'd want to create a class like kind of like where she was going with numbers and special characters, and then
Okay.
you would have an expression with
So how would I do that with numbers and special characters?
you could
Somebody else want to help?
Class features and negation of character type regular expression.
Oh, that's interesting. So you're saying it could be anything except for an alphabetic character. Okay, so we might, that's interesting. That might work. That would be an interesting way to do it. So we could do, I think it was alpha. Okay, so this is now constructing a character class that's anything except for alphabetic. Or we could have done it the way that Madeline was going, which I think was sort of creating it out of digits plus any particular special characters. Yeah, Daniel.
Is there a way to also exclude spaces, to add space to the excluded alpha?
Yeah, so okay, so this is good because this starts to get at, we start to sort of think about ideas and then realize maybe things won't quite work because this would also include spaces in there. Yeah, Chris?
Yeah, I was thinking you would then add space at the end, and then you would optionally allow a period or semicolon or comma as punctuation. Okay, question mark.
So space at the end of, you'd be saying like, yeah, I'm not quite sure how to, I'm not sure.
Outside of the brackets.
Yeah, I'm not sure how to how to deal with the spaces unless we construct it without the spaces in it. I guess we'd have to look more into how the negation works. But, well, okay, so this might work if we think about negation, but it might be easier to do it as 0 to 9, and then we put in whatever other sort of particular punctuation we think is going to be problems in there.
To include spaces, couldn't you put a space right after the caret? So that way it's not.
Right here?
Yeah, the way you search for
I don't-
space tab. Or
Yeah, I don't think that will work, because this is supposed to negate whatever comes after it.
And it wouldn't negate the total. It doesn't first concatenate space and alpha and then negate it.
I don't think so. I think it's basically negating the whole class.
I see.
Although I guess actually no, because the not ABC, the ABCD example that I had was not
Right, so you should
A,
just
B,
put a
C, D.
space.
So maybe, yeah, so maybe that we could maybe I'll just do this as a space because otherwise it won't really show up. So we might be able to do this, and this would, I think this might work. We'd have to play around with it. We might need to basically group this again in with another set of brackets. So there's a bunch of trial and error here, and lots of these things come up where you sort of have to experiment and see what works. So something like this might work. This will definitely work if we just sort of put in all the things that we want to detect. Maybe it's an exclamation point and other things. Okay, so we've constructed the thing that we're looking for. That's not enough because there are obviously going to be there might be numbers in our document, or there's going to be punctuation in our document. So what more do we need to add on to this initial thing that we've got going here? Yes.
Well, we need to show that it's in the middle of the word.
Yep.
So if we have the expression that says some number of alphabetical characters first, and then whatever this weird stuff,
Right, and then this thing.
and then it ends with some number of alphabetical.
Some other, okay. Yeah, so let's just do it for now without even looking for some number of them, just looking for one alphabetic character, but that would be sort of how we would want to do it in a more sophisticated way. So if I wanted to specify that there first has to be something alphabetic, I can do something like this, and then I can follow that by saying there has to be some other alphabetic. So now we've got it going where, okay, we're looking for any of these things that are embedded between two alphabetic characters. Anybody see, even just explicitly with what I have here, anybody see anything that's going to cause problems with what I've written up here?
The underscore, email addresses.
Yeah, okay, so email addresses, that would be a problem because I've got my add in here, right? And what else would be a problem? So I just started to sort of write things down randomly, but this punctuation can appear in an actual legitimate word, right? For apostrophe S or something like that. So obviously we didn't think this through carefully enough, right? And as I was sort of writing down these possibilities, and we'd have to, this would be the sort of start of this iterative process of like, okay, here's the first thing we might try, and then we'd sort of start to go back and forth to make it more, potentially more complicated to deal with these special cases. All right, so let's move along from that. But obviously there's a lot of room for thought in terms of making that more sophisticated. But you can sort of start to get the sense of how these things get developed. Okay, so the next thing I wanted to mention was location-specific matches. I've already sort of said a little bit about this because when I was writing up the material, I sort of mistakenly put that in earlier on. But basically, if you want to look for something that definitely appears at the beginning of a string, then you would put the caret at the beginning of the pattern that you're looking for. And if you want to find something only at the end, then you would have at the very end, you would put a $ right before the closing quote. So here's a case where I'm looking for, in text, for anything that begins with an uppercase character.
Can I just ask,
Yeah.
let's say we're looking for one character only, let's say we are looking at A. So let's say in the spreadsheet, this column with all A's or B's, and we are only looking at A. Can we use a start with A and end with it? So we have a caret A and a money sign.
Yeah, you're basically totally stealing my thunder from the next example here, which is well, okay. So this is what you're stealing thunder from. So let's come back to your question in a second. Okay, so this looks for a digit appearing at the end of the string. So that's what the $ means there. Okay, so now take a look at. Stare at this for 20 or 30 seconds, and this is basically, it should be answering JR's question. So try and figure out what this means, and I've deliberately put 2 carets in here just because this is how regular expressions are. You have to get used to sort of being overwhelmed by the syntax and just sort of trying to sort of piece your way through it and figure out what each piece means. Okay, so what do people think this is looking for? Yep.
Okay, I can tell you what I think, and you can tell me I'm totally wrong. It has to both start and end with an uppercase.
Okay, so that's not quite right, but you're getting there.
Anything that's not lower.
Okay, so this is anything that's not lowercase. So sometimes it's helpful to sort of look at these things and look from the inside out. So if I ignore this for the moment, let me just try and interpret what this is. This is a single character class that says anything that's not a lowercase character. Now the reason that it's not quite what I'm totally blanking on your name. Kelly, right? Sorry. The reason it's not an uppercase is because anything that's not a lowercase could also be a number or punctuation or space or all that. So this is any character that's not a lowercase a to z. But then what does it mean that it has to start and end, that it's starting and ending this way? Is there sort of a more real-world interpretation of what's going on here?
So, is it, the way I was seeing it, is it anything that's not nowhere anywhere in the word, or is it the word has to start and end? I'm seeing it as grabbing any character anywhere that's not.
Right, but the thing is, this is just going to match a single character, so that's the key. So the character class is just looking for a single thing, right? And the single thing has to occur at the start and the end. What's that? So it should just be looking for a single character that's not a lowercase character. Because that single character that it's looking for has to be both at the start and it has to be at the end. And the only way it can be at the start and the end is if it's just a single character. Okay? Because we're looking for a single character, and we say that what gets found has to be at the start and it has to be at the end.
Does it have to be the same one, or is it any?
Yeah, so I think this. Let's try it. So this is a good case where it's nice to try things out and make sure that I'm remembering the rules correctly. So, so can folks suggest a few tests that we can try here to try and choose from amongst these different possibilities that people have been suggesting?
The word apple with capital A and
Okay.
or capital A.
I won't ask you how potato is spelled. Okay, other things that we can look for?
Potato with zero.
Huh?
Bob with capitals.
Bob, like that?
With capitals.
Okay. Oh, right, because yeah. Either way, doesn't really matter there. Okay. Okay, or how about just B, right? Okay. Or we could say, what happens if we do this, or maybe even like this? That might be interesting to see. Okay, so we've set up some tests. This is how I usually proceed. I'm like, okay, I more or less know the rules, but I don't quite remember, and so either I have to go look up some documentation, or I just try and do it empirically and try and figure out what's going on. So now we're going to do string locate of whatever that was. So it was this, and then not, what was it, lower? Okay. Do I have it up here? I guess I just am in the wrong place. And then ending. Okay. And then tests. Right. Okay, so it is. I was right in my memory of sort of how I constructed this when I originally did this 3 years ago, or whenever it was, that it really is looking for matching a single character, and it can't be things like Bob, where it's two different characters that happen to be the same character. So it really is. It's finding a single character, and that exact character is at the start and the end of the string. So there are lots of these cases where it gets fairly complicated, even with a pattern that only has 9 or 10 symbols in it. Okay, so any questions that came out of this? Yeah, Greta?
So the part where, okay, so the lower, the one, that's what indicates for a single lowercase letter and then it negates it.
Right.
Okay, so whenever it's like that, it's always just a single.
Yeah, so anything where we've defined a character class with the outer square brackets, we're looking for a match that is a single character. And if we're trying to look for more than one character in a row in some way, we're getting to that. Although we've already seen it with this sort of syntax where we just put them next to each other in this way. But that's why these things are called character classes, because it's a class in which we're looking for a single character. Yeah, Florian.
Why is 99 not matching?
So 99 is not matching, sort of for the same reason that Bob is not matching, which is basically this is basically saying we're looking for a single character. It's not we're literally looking for one character. We're not looking for whether there's the same character at the beginning and the end. Actually, looking for the same character at the beginning and the end, that might be hard to do. That would be an interesting challenge to think about. I'm not sure off the top of my head how to do that, actually. Yeah, Mike. Yeah, so that's why I did this particular example, was to try and introduce some of the complexity here. When it's inside the square bracket, it's doing negation. When it's here at the beginning, it's doing the, hey, look only at the beginning. And part of this is just that we don't have enough symbols to use in this language, that they end up getting repeated, which is not great. I mean, this is not particularly elegant, right? Okay, so let's move on to the next idea, which is, we already sort of started to get at this when Madeline was talking about, and actually we already sort of saw a brief example of this when Madeline was talking about, I want to find multiple alphabetic characters within which I'm looking for a single weird character. And so this idea of repeating characters is encoded in this way. So the star should be familiar to you because we've already used the star as a wildcard when we were doing the Unix shell stuff, and it's sort of doing the same thing, performing the same role here. So this is just as an example. The things I want to focus on are the stars, the plus, this, and then this curly bracket notation. The fact that I'm using a digit here is just as an example. I could have put any character class or any character in here, any literal character in here as well. But this says look for any number of digits. This says look for at least one, so one or more. This could also be 0 of them. And this says look for 0 or 1. And then if you do it this way, you can basically say look for anything between, look for anywhere between 1 and 3 of these things, or 1 and 4 of these things, or 2 and 5 of these things, or whatever we put as the starting and the ending. And if you leave out one of these, then it means look for 2 or more, or you could look for, if I had a comma 2, it would look for 2 or fewer. So that's the basic way you do these things. So another example of this that then brings again this idea of doing escaping is, if I look at this says, okay, literally look for an open square bracket, and then look for the period. I guess I haven't introduced this. The period stands for any character. So this says look for 0 or more of any characters inside square brackets. Again, I have to escape that. So if I'm trying to find things in square brackets where it could be anything in there, that would be one way to do it. Okay, so let's see an example of this. So here's an example of looking for telephone numbers, and maybe I'll switch over to R so we can actually just run this. Oops. Okay, so what I'd like to do is sort of present this example to you, and it's not too complicated. We'll just sort of work through it briefly. But then I want you guys to critique this and say what could have gone wrong. What am I going to miss by using the particular syntax that I used? So I'm looking for telephone numbers. I'm looking for them in the US, sort of Canadian, Caribbean style of telephone numbers. So I'm looking for 3 numbers, 3 numbers, and 4 numbers. So all I'm doing here is I'm saying, okay, I'm looking for a digit, but 3 of them. And then, what is this? This is either a dash or literally a period, in case I wrote the telephone number as 617.443. whatever. And then another 3 numbers, and then again the dot or the minus, the dash, I mean, and then followed by 4 digits.
Can we double escape? Means that we want a dot and a square bracket.
We want a dot and a square bracket. So if you literally wanted a square bracket, you need to do the double
escape
blanks.
for the double bracket.
Yeah.
Then after that you have to do an escape for the dot as well, right?
So if you're saying if I'm looking for a bracket followed by a period,
yeah,
then you would need to do it as this. That. So you can see we build up like long, seemingly uninterpretable pattern sets of symbols when we have to do that sort of thing. Okay. So what might I be missing if I'm looking for phone numbers like this? Huh? Okay, so yeah, we can probably start to build up some, because that hadn't even occurred to me when I was asking the question, which is another reason why it's good to have multiple people. So sometimes people have the area code in parentheses, and then they have the number, so we're not going to catch that. What's that? With or without the dash. Okay, so we might have 617 space 443.
Or without space.
Or without spaces. So I did a terrible job here, right? Is that what you're telling me? Okay, anything else? Yeah, well.
Country code?
Okay, so we might have a country code. In this case, maybe we're not doing too badly because we're not saying this has to start with any particular thing. So we could find, it could be that we would match this and it happens to be there's a 1 or the country code in the beginning. So in some ways, it's not terrible that we've left that out.
If they're just
Please specify three.
Huh?
Please specify like the digits having 3 times.
Yeah, all I'm saying is if this is a U.S. or Canadian or Caribbean style number, then it has to look like this, and there might be a 1 in front of it. But I'm saying this will still match regardless of whether there's a 1 in front of it or not. Yeah. But that style thinking is definitely what we have to think about. Anything else I might be missing here? So maybe it's not too bad. Maybe we just have to think about these special cases. I suppose there might be other things that people put between to do the separation. Although I guess I left out the 617 space 443 as well. Okay, so we could take this and then develop it a little bit further. And then, of course, we'd get into a whole other can of worms if we started if we were trying to find phone numbers that were not just in the U.S. or Canadian or Caribbean style, and then it would become much more complicated. All right, any questions at this point?
So the double backslash to exit, I guess, is that
Escape,
specific?
yeah.
Is that specific to this package, or is that specific to Perl? Or?
So that's that's specific to R that we need the double backslashes. If you're using regular expressions in other contexts, I believe you would mainly just need 1 backslash. Yeah. Okay, so let's see what else have I got here. So let me show you one more example. I may come back to this challenge of extracting email addresses next time. That would be a good one to talk through. But let me just present to you a little bit more in terms of one more type of syntax, which is we often are going to want to use parentheses. And the way that parentheses get used is a couple different ways. So basically, parentheses are used for grouping. So if I had wanted to say, instead of doing, there was a little bit of redundancy here in what I did. I did the same thing twice in a row here. I did the digits and then the dash business and then the digits and then the dash business. I could have replaced that with a grouping operator, which is the parenthesis, and a 2 and the number 2. So I could have done something like group together the 3 digits. And the, what was it, the period and the dash. Oh, and there was a 3 here, right? So this now, by doing this grouping, this forms a unit that says 3 digits followed by one of these guys. And if I group it together, I can now do my repetitions directly on that. So I could have done this as 2 repetitions of that, and then I could have done this as the one where I have the bit about 4 digits at the end. Can the what? Like this?
Yeah.
Yeah, this should be fine because I'm doing the escape, and so it should recognize this as literally a period or a dash. Okay, so now I've used this grouping to be able to allow myself to repeat a whole pattern instead of just repeating some discrete thing. So that's quite useful. And let me see what else I want to say about this. Where am I here? Okay. So here's another case where it came in handy. And this actually goes back to Guang's point about the country code. So I'm saying, okay, suppose I did explicitly want to be. I don't really need to do this in this case because if I don't put this in here, it will match regardless of whether the 1 is there for the U.S. country code. But one way that I could say, yes, have a 1 in there. Maybe there will be a 1 there, or maybe there won't be a 1 in there for the country code. Is I could say, okay, a 1 followed by, again, then my dash and my period. I'm going to group those together. And remember what the question mark is. That says 0 or 1 times. So this might or might not occur as in front of the rest of the number. And I guess here I just wrote out what I had written out, over there. Although you'll notice I did something a little bit more here. I said, oh, maybe sometimes people will leave off the area code. So in this case, I'm saying maybe there'll be one set of 3 numbers and then another set of 3 numbers, or maybe there'll be only a single set of 3 numbers. So anybody see anything wrong anybody see anything that this would detect that actually shouldn't be detected? Question mark is 0 or 1 cases, repetitions, yeah. So I wrote this out. When I was first writing this out, I was like, oh, let me try and be sort of snazzy about detecting the country code and then about dealing with the people might include or exclude the area code. But something could go wrong with this. There's a case that could go wrong here. Right, so it would detect as if this is a phone number detection code, it would detect 1-634-9827 or whatever, and that's not actually a legitimate number. So in some ways I've maybe tried to get a little bit too fancy here. On the other hand, if I'm not really expecting this to ever come up in reality, then I'm never going to match it and it'll be okay. It would only be a problem if this were put in there and it weren't actually a phone number and I detected it as a phone number. Okay, and then just briefly, the other way that, we'll come back to this and I'll say more about it next time. The other way that, well, there are two other ways that these parentheses are used. One of them is to basically do with the pipe to say, if I want to find this sequence or this sequence, then I can do it with the grouping operator and then the pipe as an OR. And this is basically saying, oh, I'm going to look for either HTTP or FTP. So that would be useful if I'm looking for URL type information. And then the other thing that the parentheses are used is whenever I use parentheses, I can actually refer back to whatever was found as the pattern that got matched in as being grouped inside the parenthesis. And this allows me to do some nice things with replacement. So I won't go over this now, but we'll come back to this next time. So why don't we quit there? What I'm going to do, I'm going to send out an announcement once I get back to my office and give you guys a few mostly fairly straightforward problems to practice with before Friday. And so when we come in on Friday, I'll have you guys, I guess I'll have my panel, whoever the panel happens to be, put up their solutions, and it'll be interesting to see. For some of them, they'll be very simple, and you guys will all get the same answer. But then there'll be a couple where people will have different answers, and again, it'll be interesting to look at what the variety of different things that people came up with is.